Knowing all these tricks that we just talked about is great, and it's really gonna help you get great quality data. But there's still more that we have to think about our SDS page. In the science section, Darren has explained to you how important it is to choose the percentage and the type of your gel. He has also covered how choosing your running buffer can really influence the outcome of your SDS page. Now, it is equally important to make sure your gel type matches your running buffer. For example, a tris-glycine gel should be run with a tris-glycine buffer, whereas a bis-tris gel could be run with an MES or a MOPS buffer. In this later example, the MES buffer is optimized to run small proteins, while the MOPS buffer is great for larger proteins. So don't forget to carefully choose not only the type and percentage of your gel, but to match it with the appropriate running buffer. The next topic that we have to cover regarding SDS page is how to choose the voltage or the current that we're going to use. You may have noticed that different researchers have their own preference. Some people like to set a constant voltage, while others like to set a constant current. So which one is best? Our challenge is going to be that throughout the run, ions are going to be released from the gel, which is going to change the resistance as the run happens. Ultimately, one of your variables are going to change, either your voltage or your current. The good news is you get to choose which one remains constant. So if you choose to set a constant voltage, what's going to happen is that as resistance increases, the current drops, so you don't have to worry too much about an increase in temperature. On the other hand, that run is going to take a little bit longer. If you decide to do the opposite and set a constant current, what's going to happen as the resistance increases is that the voltage is also going to increase, leading to a higher temperature. And that can be a little bit dangerous because as temperature rises, we may end up having the gel melting, and we may also end up having protein degradation. Polyacrylamide gel melting can lead to poor protein resolution and separation, which ultimately causes artifacts such as warp bands. Now, if we end up having the other issue, which is protein degradation, two things can happen. Once again, we may have issues with artifacts such as smearing and warp bands, but more importantly, we may have issues with our primary antibody being able to recognize the antigen downstream in the protocol, since the protein degradation might affect the antigen that that primary antibody is trying to recognize. So what is the solution? Well, the solution is that we want to try and keep the temperature under control. So most researchers choose to use a constant voltage. That doesn't mean you can't run your gel at a constant current. You just really have to monitor the temperature very closely. Ultimately, what we want to ensure is that neither the voltage or the current get too high. Again, you can have really severe consequences if that happens. I know it's tempting to try and run the gel as fast as possible to get it done and over with, but that could really compromise your data. Now, another tip that we have is to start your run at a lower voltage, probably something close to 60 volts, for about 20 to 30 minutes. That is meant to allow your proteins to slowly enter the stacking gel and be properly stacked before they go into the separation gel. After that initial slower voltage, you can actually increase the voltage to something like 120, 150 volts, depending on the gel that you're running. Controlling the temperature throughout the SDS page process is going to be very important for several reasons that we already discussed, but also to avoid having artifacts such as a smiling gel. There's several reasons for a smiling gel, but the main one is uneven heat distribution across the system. As the temperature changes, so do the properties of the polyacrylamide gel. If the temperature is uneven across the gel, the lanes are going to run at different paces, which explains why we end up having the smiling gel. So don't forget to check the specifics of your gel type, your gel matrix, and your running system to make sure you have a smooth SDS page process. Now, let's go ahead and watch the mechanics video so we can see in the lab setting how the gel preparation and gel running takes place.